Okay, so this is scientific notation. So some tortoises have been known to live more than 150 years. Or in other words, that is 3,850,000,000 seconds. Express this number of seconds in scientific notation. So what's scientific notation? So you might have seen numbers written like this before, 1.5 by 10 to the power of 7. That's referred to as scientific notation. It's a way of writing really, really big numbers or really, really, really small numbers in a much shorter way. So for example, here I have 3,850,000,000 seconds, but I want to write it in scientific notation. Now, typically, you write it so that you have a number here that is less than 10, so it's always like 1.5 or 2.3. You will always have this multiply sign. You will always have this 10, and the number here might change. So let's deal with getting the first number first. So I have 3,850,000,000, and I need to turn that into scientific notation. What you do is you go to the very first number and you put a decimal place straight after it. Now, what you then do is you count how many decimal places would actually get you to the end of the number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that number 9 jumps, 9 decimal places. So you take the number you have here, 3.85. You write multiply by 10. You always write multiply by 10. And then the amount of numbers you jump to get to the end is what you put here. So 3.85 by 10 to the power of 9. That is 3,850,000,000 in scientific notation. Having a look at this one here. The last one we had a really, really big number. Here we're going to deal with a really, really small number. So hair on the human body can grow as fast as 0.0000000043 meters per second. Express this in scientific notation. So it's similar enough. So let's just write it down. 0.0000000043. Well, we need to put the decimal place somewhere, so we have a nice number to begin our scientific notation with. It has to be less than 10, so I'm going to put it here, 4.3. But this time, I'm not going to jump to the right, I'm going to jump to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. To where the decimal place would normally be. So again, it's 9 places. So it's 4.3 multiplied by 10 to the power of, now this time we jumped left. So because it's a really, really small number, it's going to be to the power of minus 9. So if you're going left, it's going to be the power of a negative figure. But if you're going to the right, it's the power of a positive figure. Let's look at one more example. Write this reciprocal of 10,000 in the form 1 by 10 to the power of n, where n is an integer. That just means put it in scientific notation. So what is a reciprocal? You might remember that from first year. A reciprocal kind of is upside down. So the reciprocal of 10,000 is 1 over 10,000. Now, there's a couple of different ways we could do this. We could put this into our calculator and hit the equals button, and you'll get 0.00001. Okay. Another way of looking at it is just, let's break the 10,000 into the scientific notation. So we've got 10,000. I want my decimal point to be less than 10, so I'll put it here. I'll be jumping to the right. 1, 2, 3, 4 jumps. So it's 1.0, so just 1, by 10 to the power of, we jumped to the right, so it's 4. So that's what 10,000 is, but we have 1 over 10,000, so it's 1 over 1 by 10 to the power of 4. And you might remember from indices, if the number is underneath the line, it's a power of a negative number. So therefore, it's 1 by 10 to the power of minus 4.